Alright, so we've started talking about hypothesis testing in class, but one of the things that we have to talk about is whenever we're using data to make a decision, we're never 100% sure in our answer. And so when that happens, there's always a chance that we make an error. So to first understand about the errors that can be made during a hypothesis test, we're going to sort of remove ourselves from stat world and think about it in a context that most of us are much more familiar with. So we're going to look at the idea of just someone being tried for a crime. So generally speaking, in the United States, we're supposed to be innocent until proven guilty. If we assume that, then our null hypothesis, again what we believe to be true until we know otherwise, is that the defendant is actually innocent. The alternative, or in instance the goal, why we're actually having the trial in the first place, the goal is to try to show that the defendant is guilty. So innocent until proven guilty. In this situation, there are two different errors that could occur, and we're going to talk about the consequences that could result if those errors did happen. So the first thing we could find is that the defendant is guilty, but in fact, they really are innocent. So if I think about that, so first of all, that's a bad decision, right? We find them guilty when they're innocent, so I am committing an error. But what bad things could happen if that were the case? So, right, they could go to jail for a crime they didn't commit, right? So they might have to serve some time there. They might have a fine they have to pay. Right, and depending upon the actual crime that they committed, they can have different kinds of consequences like that. But I mean, some other things that are still a big deal to people. Right, I mean, your reputation has definitely been tarnished if you're found guilty for something. I mean, especially it's worse when you haven't even actually done it. Right, so your reputation is at stake. But another big thing to think about here is if you are found guilty but didn't do it, someone else got away with it. Alright, so I mean, if you're being guilty of it, they're not going to go out there and actually look for the person that did it. So someone else did it and they got away with it. All of these things are bad things that could happen if we were to commit this error. Now, opposite, we could find the defendant not guilty when in fact they are guilty. Now, just as a moment to kind of discuss about some things I've talked about in class, of that, you notice that I never come back and say the null hypothesis is true. Right, so I mean the verdicts, our options are guilty or not guilty. I'm never going to come back and say that I find the defendant innocent. I come back and find them not guilty. So we are kind of picky with our wordings. We're going to find them not guilty when in fact they really are guilty. Alright, so what is so bad about that? Well, if we let someone get away with it, right? So first of all, the criminal gets away. That's definitely a bad thing that could be happening here. Because of that, right, we could have someone who ends up being a repeat offender. And again, depending upon how bad the crime is, this could be worse than in other situations. Right, and someone else may take the fall. So if they don't find you guilty, they might end up finding someone else guilty. Right, so again, all of these things are bad. Now what I want you to think about for a moment is which one of these two things do you think is worse? Do you think it's worse to find someone guilty when they're really innocent, or find someone not guilty when in fact they really are guilty? Now, depending upon your situation, maybe what you've gone through, you may have a different reason for picking one of them to be worse than the other. I mean, maybe if you were a defendant at some point, or if maybe something happened, it might change things. So which one am I going to say do you think is more serious? For me, I'm going to say it depends. Now, if I agreed with the criminal justice system overall, they say, it's better to let 1,000 guilty people go free than to punish an innocent person. So they would think that the first one is worse. Now, that's just one perspective. So what I'm going to say it depends upon. So for me, if I'm trying to figure out which one of these things is worse, the first thing I'm going to care about is what kind of crime are we talking about. If we're talking about, something with like petty theft, or if we're talking about murder, that's probably going to make a very big difference to me on which one is worse. What may also depend on me is my perspective. And by that, I just simply mean what angle I'm coming at it from. If I'm the defendant, to me, obviously the first one is going to be worse. I'm going to be very upset if they find me guilty when I didn't do anything wrong. And sadly, I might be totally okay with them finding me not guilty even if I did actually do it. Right, but if I think about it from the opposite perspective, so if somebody hurt someone in my family, man, this one's going to make me really mad if it happened. And that's going to be really bad to me. I mean, not that I want this to happen either, but man, if someone did it and they got away with it, I'm going to be very upset if someone hurt someone in my family. Right, so the perspective is going to make a difference as well. Now, before we move this back into stat world, let's kind of talk about it slightly outside of this context as well. So what I mean by a perspective as well is, for example, if I'm looking at something something I buy. So let's say, for example, I drink my Diet Dr. Pepper a ton in class. And so we're talking about Diet Dr. Pepper and making sure that I get what I'm told. Like, right, so if they tell me there's 16.9 ounces of pop in my bottle, I want to get 16.9 ounces of pop. Now, as a customer, I want my 16.9. Right, and I definitely would be okay with them giving me something more than 16.9 as well. Because it doesn't hurt me as the customer. I'm only going to be upset if they don't give me as much as they say. Whereas I'm taking at an angle from the actual business, they're going to have to worry about both sides of things. Right, so perspective does make a big difference, because for them, if they put too little in it, they're going to upset their customers. If they put too much in it, then that means that they're going to be losing their profits, right? So the perspective, like them losing money as a customer, doesn't impact me at all, right? So that's not a bad consequence to me, but that's definitely a bad consequence for them. So depending upon just what angle I'm coming at it from is going to make a difference there as well. Now taking it back to stat world. So there's two types of errors. There's what's called type 1 and type 2 error. A type 1 error happens when you reject the null hypothesis, when the null hypothesis is actually true. So that would correspond to us back with our example up here. So if I reject the null hypothesis, that means I'm going to believe my alternative. That means I'm going to find the person guilty. But when the null is actually true, they're actually innocent. So that's exactly what the first one is. So I find the person guilty, I've rejected the null, but the null hypothesis is actually true. Now a type 2 error is when the opposite is true. It is when you don't reject, or what we've been calling fail to reject. But if I don't reject, for it to be an error, then it actually needs to be false. So when I talk about defining type 1 and type 2 error, I usually assume that you're going to remember what an error is. So it's easy to remember which decision goes with which. So a type 1 error is when you reject. A type 2 error is when you fail to reject. So kind of the twos go together. But then hopefully you remember what the error is. So what's going to be bad if I reject the null hypothesis? Well, if the null hypothesis is actually true, that's the error. What's the problem if I don't reject the null hypothesis? Well, the problem that if I do that makes it an error, so it's actually wrong. Okay, so usually you can remember what an error is. Now what we want to talk about are the probability of these two errors actually happening. And since they are errors, we would like the probabilities of these things happening to be small. So the probability of a type 1 error, this is finally where we get to see the one symbol that we've used so much. This is what alpha actually is. This is your significance level. So now you probably understand why, generally when you've seen this number, it's been a pretty small number, because that's actually your probability of a type 1 error. That is the chance that you are going to reject the null when the null is actually true. Now the probability of a type 2 error is actually a new symbol for us. We haven't seen it before. This is actually your Greek letter beta. But the important thing I want to note here is what it says here in parentheses, that this is not 1 minus alpha. These do not have to add up to 1. There is not a 100% chance of committing an error. So that this is a separate number. And we'll talk about how it is somewhat related to alpha here shortly. The final fill in the blank before we do our chart here, let's talk about actually one of the good things that can happen, and that is what's called power. So that's the first thing I want you to realize about this. When I talk about this power, it's actually a good thing. And the reason why it's good is the probability you reject the null hypothesis when you should. So basically you're finding the person guilty when they are actually guilty. So this is actually a very good thing for us to happen, and its probability is 1 minus beta. So it's a lot of information, a lot of probability that's showing up. So we're going to try to summarize this together in a chart to see if the chart helps explain what's going on. Alright, so there's going to be 4 total possibilities. And over here, we're going to put our decision. In our decision, we can either decide that we are going to reject the null hypothesis, up there, or we're going to decide to not reject it, or fail to reject. So those are our only 2 decisions when we do a hypothesis test. Then what we have is reality. Now, truth being told, we don't know reality. That's why we're doing a hypothesis test here. So what the reality is, either the null hypothesis really is true, or the null hypothesis really is false. Right? If I actually knew which of these 2 is true, I wouldn't actually be doing the hypothesis test. But so just like when we do a crime, either the person really is innocent or they really are guilty. Now we're actually having the trial to find out which one we believe to be true. Right? But there is a truth or a reality that's going on here. So taking about the ideas that we learn, we have to figure out where they fall in our boxes. So if I reject the null hypothesis, when the null hypothesis is true, first thing I want to think through, is that a good decision or is that a bad decision or an error? So if I reject the null, I'm not going to believe the null is true, but the null really is true. So this is going to be an error. Which error? This is our type 1 error. Now if I reject the null hypothesis, when the null hypothesis really is wrong, or this is our equivalent of finding the person guilty when they really are guilty, this is not going to be an error. More specifically, it's on your prior page, but this is what our power technically is. Or we're rejecting where we actually should be rejecting. Now, if I don't reject the null, when the null is really true, or in a sense this is, I'm going to find the person not guilty when they're actually innocent. Right, that's a good decision. So not guilty, they're innocent, that's good. There's no error here as well. This one does not actually have its own special name. This one has its own special name because generally your goal is to reject the null. When you do a hypothesis test, it's kind of why it has a special name. You probably see by default, if we do not reject or find the person not guilty, when the null hypothesis is false or the person actually is guilty, that's going to be an error. So we're going to say basically the person is not guilty when they actually are guilty. That's going to be an error. That more specifically is our type 2 error. Now that we have the names on here, I'm going to put the probabilities that correspond with it. So the probability of our type 1 error, that's our alpha that we see above. The probability of a type 2 error is our beta, which we see above as well. That's the probability of power above right here. That's 1 minus beta. The only one that I didn't give you, because we didn't want to talk about it having a special name, down here is actually 1 minus alpha. So those are the corresponding probabilities of being in any box. Now, if you actually stop to think for a minute and aren't just trusting everything I say, if you start kind of doing the math there, those probabilities add up to 2 in total, which doesn't really make any sense because, right, there's only 100% or a probability of 1 of things in total happening. So why does it add up that way? If you'll notice, each of the columns adds up to 1 or 100%. And the reason behind that is either this is really true or it really is false. So if the null hypothesis is true, this is my chance of being here, this is my chance of being here. If the null hypothesis is false, this is my chance of being here, this is my chance of being here. The problem is, of course, I don't know which of those two things is true. Right? I mean, if the null hypothesis is true, there is no way that I can actually commit a type 2 error. Right? There's no way. I just don't actually know which column I'm in. So that's a little fuzzy, I know. But it's the idea to think about really, basically if the person really is guilty, there is no way that you are going to find the person guilty when they're innocent. Right? There's no way that you're going to falsely put someone in jail. If they really are guilty, that's where they belong. Right? So there's that idea showing up there as well. Now, how are these values related to each other? The first thing to notice is that we do have control over that alpha. Notice that we can set that number for our problem. Here's sort of the downfall. So, I would really like the probability of both alpha and beta to be small, because that means my chance of either error happening is small. Now, generally the problem is generally if I make one of them smaller, so if I make alpha smaller, that's only going to increase your chance of a type 2 error. So as one goes down, the other one goes up. One of the best ways to reduce either of those chances, though, is an increase in the sample. So the more data you collect, the better chance that you're going to make the right decision overall. So just like in a trial, the more evidence we collect, hopefully the better chance that we make the correct decision in the end. So that's the same idea. So a question that then remains is how would you actually set your significance level based upon the errors that we have? So what I have to think through goes back to this very beginning. Figuring out which error is more serious. And like I said, it depends upon the situation. So that's going to be the first thing I figure out. So I'm going to first look at consequences of type 1 and type 2 errors. To kind of see which one is worse. And then based upon that, I can decide how I'm going to set it. So if I do that, and then a type 1 error is worse than a type 2 error, that means that I want my chance then of a type 1 error to be pretty small. And notice alpha is something that we can set. So generally speaking, when that's true, we set alpha to be 1% or 0.01 in decimal form. If instead a type 2 error is worse than a type 1 error, that means I would want beta, which is my chance of a type 2 error, to be small. But notice I can't control beta. If I want beta to be small, I can just flip this increase and decrease around. So if I want a decrease in beta, I can increase alpha. And so generally the biggest I see starting for an alpha level is about 10%. So generally we use about a 0.1 in that case. Now the last thing that could happen is you go through and you assess the errors and they seem about the same. Right? One is not really worse than the other. So I don't need to worry about making alpha smaller, I don't need to worry about making beta smaller. This is generally when we use the standard 5% significance level. So this video was primarily just an introduction to errors. So notice here we didn't talk about context, any problems that we have. So when we actually start the example the next time in class, we will actually see what is a type 1 error in this specific example, what exactly is a type 2 error in this specific example. We'll talk about which one is worse. We'll talk about actually setting an alpha level. So hopefully after we apply it to a problem, things make a little bit more sense. But hopefully right now the idea of that there can be an error that happens, right? There doesn't have to be an error, but there could be an error that actually happens. And wanting to make that probability as small as possible makes some sense. So we'll pick this up in class next time.